We log into the RStudio environment and we go to the home directory, and under Dream High 2025 TCGA clinical data, we open the R Markdown file for this activity. We can minimize this screen, and the first thing we're going to do is go up here in the upper left to File, Save As, and give it a new name. So now we have a new file and we're saving the original for reference. Under Title, put your name, so it's your activity. And there's a lot of text here that you can read offline. You can load in the imager package to view the images with the load.image function. I'm going to skip that. Instead, I'll start right here at loading the data we're going to use in this activity. We use the load function, and our data exists in this directory, home data. And this is the name of the data file. It has the .rdata extension. So let's run that. Now, because of the argument verbose equals true, it's telling us what it's doing. And let's look in the environment tab here. We see that we have loaded an object. So this is TCGA breast cancer clinical data frame. So data frames are like tables. So we've used the dimensions and head functions before, but before we move on, let's take a global view of the data with the view function. That opens a new tab, and we see a very large data set. Scroll down, there's many rows and a number of columns or features. You can scroll through that and spend some time with it. So we're going to be using indexing in this course a lot. And what that means is we have something with two dimensions, like a table or a matrix. It has rows and columns. So to select out particular cells, or here even just one cell, the first position refers to columns, the first position refers to rows, the second position to columns. So the row and column fields are separated by a comma. And when we run this, we're picking out the cell that's in the first row and the first column, and that is this patient's anonymized barcode. So let's pick out the first row and the fifth column. And we get the number 55. If we go back to the data frame, the first row and 1, 2, 3, 4, 5, yep, we get the number 55. So there's some exercises you can do to get used to indexing two-dimensional objects like tables and matrices. You can work through the practice. I'm going to skip that to our next section, which is examining some of the features in this table. So the column names are the features of the patient data frame. So let's get a summary of the gender for this patient cohort. And a lot of them do look like they're female. Let's see how many there are. And we will use a function called table. So table will take in a particular column. And in this case, we want the gender column, which is column number 2, and provide a summary for us. So table will always take a list or array of values. So most of the patients are female, but we have 12 males in this cohort. There's another way to pull out that column, and that's using the dollar symbol to specify a particular column. So what if I delete that now and I put in the dollar sign, and R gives me a menu of the different features to choose from. So we'll use this in a number of places in this activity. So I'll choose gender. Yep, and we get the same values that we obtained before. So a number of ways to choose columns. Some of the columns have many values in them, like age at diagnosis. So when you have more than just a few values, something like age, which is a continuous feature, we can take any value really. We see some patients that are 85 and others that are 39. We can use a histogram with the hist function to get an overview. We'll do what we did with gender. We put a $sign after our table name and pick the feature that says age at diagnosis. So we get a nice histogram. This takes a normal distribution approximately, and we'll talk more about normal distributions when we look at gene expression data. We can add a few more arguments to histogram. We can put a label on the x-axis and a title. So label and title have to appear between parentheses. So when we run this with the extra arguments, we get a nicer looking graphic with a title and the x-axis labeled. And what a histogram tells us is how many patients have an age in a particular bin. So for example, we have like a little less than 150 patients that are between 50 and 55 years old. So there's more information here on histograms and the normal distribution that you can take a look at. And now we're going to start considering the different hormone receptors on breast cancer cells. Let's scroll to the last three columns of our table. We have estrogen, progesterone, and HER2 receptor information. We're going to call it ER, PR, and HER2 for short moving forward. So let's see what information we have for the estrogen receptor, the ER receptor, using the table function again with the $sign, pulling out that column. And there are ER negative and ER positive samples, and then some that weren't evaluated and some that were indeterminate. We kind of consider these as missing values. So let's run that. Oh, we did that already. Okay. We can do the same thing with the progesterone receptor, the PR receptor. Pull out its column, create a table, and we have some PR negative and positive patients. If we want to find out how many patients are ER positive and PR positive, we can use a more complex way to pull out, to do indexing, to pull out particular rows. You want to get those rows that have ER receptor positive and PR receptor positive. So in the row field for our data frame, this is an indexing exercise. We use the square brackets, and the first here for row is a very long expression, and we're using logicals. We want all the cases where the values for estrogen receptor are positive, that's the double equal sign, and then we have an and function because we want it also to be the cases where the PR receptor is positive. And we don't put anything in the column field because we want to pull out all the columns. So if we run that, we find we use the nrow function to see how many patients meet these criteria. And there are 672 ER positive, PR positive breast cancer patients. And we can use the print and paste functions. We can paste together some text and the number of ER positive, PR positive patients and get a better output for our results. There's another receptor there, the HER2 receptor. You can make a table for that as well. But let's go down here to the section on triple negative breast cancer. So the reason why we want to know the receptor status for these cancers, so for the patients with ER positive, PR positive cancer, there are many drugs that can block receptor function. So if there are these receptors on the breast cancers, that makes it easy to treat because there are many drugs. But if the cancer cells are missing receptors, there are fewer treatment options. So it's important to know we don't want to give someone a drug that's not going to be effective against their particular cancer. So triple negative breast cancer is the most aggressive and difficult to treat. So we're going to do this something similar to what we did with the ER positive and PR positive to pull out that information. But instead, in the row field, we'll have an even longer expression. But we want the cases with ER, PR, and HER2 receptor equal to negative. And we put negative in between the quotes because we know we have positive and negative values. We want the negative, and there's an and after each of these expressions. So all of this is together in the row field in parentheses. So we have a parentheses at the beginning and the closing parenthesis at the end. So we'll run that, and we find that there are 114 patients that are triple negative breast cancer. But we saved it to a new object called TNBC. That's a new table that contains information on these patients. So we can work on that table as we did with our previous larger table. We can view it and double check that these patients all have negative for the 3 receptors. And we can also use the table function on this new data frame we created. And all of the patients in this cohort with triple negative breast cancer are female. So we can use the table function to look at other features, for example, histological type. And you can read about what histological type is. Let's see what we get. So there are quite a number of different types of cancer. There are some obviously that are missing. We have 774 for infiltrating ductal carcinoma and 201 for infiltrating lobular carcinoma. So those are the 2 most common cancer types. And you can compare that back to the microscopy images we had of ducts. So let's create an object called n_ductal, and that is going to include our table information for histological type, but pull out a particular type of cancer. So we create the table, which is just a list of the different features and how many instances the features for each feature. And then for a particular feature, we're going to index that particular cancer. So we copy it from above because we want it to be to have the right format, and we paste it in between the quotes. So we get the number of patients that have infiltrating ductal carcinoma, and we can convert the number into a percent. Since we saved it as an object, a number, we can divide it by the total number of patients and multiply that by 100. And then we'll use the paste and print functions again to get a nice result. So just to give you an example of what you might want to do, we could also look at the percentage of patients with infiltrating lobular carcinoma. I'm going to copy that, and I'll put that here. Now it says infiltrating lobular carcinoma, and I would have to change that. I should change it everywhere. I should make a new object. But for time's sake, I will just change it in my print statement. So there are 19% of breast cancer patients that have infiltrating lobular carcinoma. And then below is your work. So you're going to do the DREAM challenge on pathological stage and also these exercises on indexing. So let's save the file. And I'm going to knit it. I want to create a report. So I get my HTML code here. Now I want to publish it. So I get a URL on RPubs. So I click the publish button, and I do want to publish it to RPubs. So it brings me to the RPubs page. Now, if you haven't already created an account, you can do that here. Or if you have created an account, you can put that information in. So let's see, I'm going to use my, I have several accounts. I'm going to use this account. I've already saved the password, and then I will sign in. And I can put a title for the report. Clinical data from TCGA, and you should also put a little description. I'm going to continue, and now my activity is published, and it has its own URL, rpubs.com, with my username, and this is the number for my activity.